Hey everybody, this is Larry. This is day 21st of the July Leetcode Daily Challenge. Hit the like button, hit the subscribe button, let me know what you think, and let's get started on today's problem, word search. Given 2D word and a word, find if the word exists in a grid. The word can be constructed from letters or sequential adjacent cells, where adjacent cells are those horizontal or vertically neighboring. The same letter cell may not be used more than once. So this one is a perfect candidate for backtracking. Maybe nope. 1,000 maybe a little bit tight. So the tricky thing is just figuring out exactly, like, it's a little bit of a guessing game, a little bit, to be honest, because you can definitely, given that n is less than 1,000, you can definitely, depends on the test cases, because you can definitely do some weird thing with 2 to the n or something like that, and that would be good because, for example, you can have something like, you know, a just a lot of a's, and then maybe a b at the end or something like that, and then and maybe don't even need all of them to be a's. Let's just make them whatever. But you could essentially force a way such that you have 2 decisions at every step of the way or something like that. Maybe I messed this up a little bit. Yeah, I think this something like that maybe. And from that, the complexity is going to be really tricky. But I'm going to try with backtracking and then see if it's good enough, and then if not, then we'll explore different pruning or something like that. We'll kind of see. But this is yeah, I'm gonna get started now then, mayhaps. But yeah, so then let's just do rows is equal to length of the board, columns is equal to the length of the board sub 0. But let's check if rows is equal to 0, then return false. Unless word is, yeah, well, I mean, I guess that's constrained, but I always try to make this more of into, just getting used to it a little bit more. Oops. So let's have a visited array, which is times columns for. Cool. And then now let's we have a depth for search, but then let's kick it off first. So let's, for x is in range of rows, for y is in range of columns. If board of xy is equal to word sub 0, so that means that we can kick it off. Let's go. Yeah, let's if find xy 0, return true, otherwise it return false. And then now we could do our find function of x, y, and then the index of the word. Let's just check again if this is not equal to word sub index, then return false. Otherwise, we want to set visited of xy is equal to true. So this basically, we don't go back and forth, or we use the same cell more than once. And then now we can go for. I usually write it this way. In different languages, you can write it in different way, but basically, I'm just enumerating all the possible dx/dys. And I generally recommend you do it the consistent way all the time. I actually don't, so I'm a little bit bad about it. And what I mean by that is that if you do it the same way, then you're less likely to have typos, ideally. Otherwise, maybe a little bit trickier. So yeah, so for the nx and y is equal to x plus dx, y plus dy. Let's check whether they're in bounds. So if 0 is less than or equal to nx rows, and 0 y, and we haven't visited yet. Then we can go. Let's just yeah, if find of nx and y index plus 1, return true. Return true. I missed the base case, of course, so I'll fix that in a second. And at the very end, return false, but we have to for this is backtracking, we have to reverse the state, so let's set this back to false. Yeah, and then also if actually before this, if index is equal to n, return true. We have to set n is equal to the length of the word. So yeah, so that's going to be good enough for me to kickstart. I mean, it's fast enough because the thing is fast enough, so I don't know. So I think what I would recommend is conceptually it's just having really tough test cases, but in this case I think it's really depending on the test case, because at some point it's going to be exponential as backtracking, so it's not, you know, like my worst case may not be the test case worst case, and there's a little bit of a guesswork, a little bit of mind reading. So so yeah, let's kind of submit and then see if we get it fast enough. Maybe it's a bit too slow then. So then we have to do a little bit more. That was the system. So wrong answer. Actually, did not expect that. Also did not expect this. But apparently I have a wrong answer. For 1 2. Oh, that's interesting. That's a really subtle bug that I did not do. But basically what happens is that because I only go to n afterwards, so maybe usually that's how I would structure my case, and maybe I would have had to kick it off a little bit differently. So this is actually a big miss. But now if index is equal to n-1, so if we already match the last character, then we return true. Okay, that's a pretty interesting bug, because so the thing is that with your last character you're never going to match this, or not never, but it's possible that you don't visit another cell, so that's why that's the wrong answer. Let's try again. I actually expected TLE, but okay, so maybe not, because the test cases are weak. But in a way it's a little bit odd, because the test cases have to be weak for you to pass this, so it's a little bit of meta guessing a little bit, because if the test cases were strong, then no one is passing this, because the constraints are pretty big. So it's a little bit weird, right? And definitely on an interview I would definitely ask all these questions, like, hey, you know, this is what I'm doing, is it okay, and stuff like that, just to make sure that you're confident before you implement, and that you show that you're able to work with the interviewer to come up with a solution that makes sense before implementing it, because otherwise, I mean, and of course it's hard for me to do it, you know, talking to Leetcode, so so that's why I'm making, you know, all the assumptions a little bit out loud, and just submitting to test that case. So I did have a little bit of a base case mistake, but yeah. Let me know what you think. So it is exponential in complexity in both. I mean, in space, you could say that it's it's linear in the size of the board and word, because we constructed a visited array, and then the stack length is the length of the word. But otherwise, the time is going to be exponential, because you can construct something really nutty, and I kind of gave a hint of it, where you just, you know, and this is like a classic 2 to the n construction, where like for each cell you could go like up, down or left, and then down or left, and down or left, or sorry, down or right, down or right, down or right, so like it's a diagonal, and then at the very end, you know, there's roughly 2 to the n cases of getting to that cell, and that's why it's 2 to the n. But you know, and you have to suspend your belief a little bit, to otherwise, you know, nothing's going to run for this case, because and in what I said was the length of the board, and now it's going to be way too long. But yeah, anyway, that's all I have for this problem. And also, that's not to say that complexity is 2 to the n, but it's at least 2 to the n, because you probably construct things that are even crazier given these constraints, but that's just one construction that will force exponential one time. But yeah, that's all I have for today. Let me know what you think. Hit the like button, hit the subscribe button, and I will see y'all tomorrow. Bye bye.